dilation is when a shape grows or shrinks, like when it gets bigger or smaller. I showed a little example here. We have our original square and then it grows and it gets bigger to this square. One of the things that you need to know, and I will continue to introduce different aspects, but one of the things that you need to know is it's related through what's called a scale factor or like a multiple. So if I can multiply this side by 4 to get this side length, then I can multiply this side by 4 to get this side length. And that number that I'm multiplying by is called a scale factor. And we'll get into that in a second. For this first set of questions, it's all about building concepts, and then we can bring in the numbers after that. So for this first set, it says use figure and point C. Use a ruler. We're not going to use a ruler. We're just going to eyeball it. To draw the image of the figure under a dilation with center C and scale factor R indicated. So here, R equals 2. That is the scale factor. That is the number that we're going to be multiplying this by. So this shape is going to get 2 times bigger because the scale factor is 2. And then C right here is called the center of dilation. And this is where we're dilating the shape from. What does that mean? Let me zoom in a little bit more. Okay, so what we're going to be doing is, in addition to this shape getting 2 times bigger, which it is, the distance from the center of dilation is also going to get 2 times longer. So if I were to draw a segment from the center of dilation to one of the points on my triangle, like this, when I dilate it by a scale factor of 2, this length is going to get twice as long. So I'm going to draw this segment like the same length, same direction, and make it like twice as like that. And so this is going to be the new point on my bigger triangle. And so I'm going to do that to each one of these points on this triangle. So like this length right here, I need to double it like that. And then this is the new point of my triangle. And so same thing, drawing a segment from C to this point. And then this segment needs to get twice as long. I might even like measure it with a piece of paper. Again, we're just building concepts, so it doesn't have to be perfect. So this length right here, I'm going to just double it like this. And I get a new point. Okay, so then these are the new points of my triangle, and I just connect the dots. This shape is twice as big as this one, like all the side lengths are twice as long, and each point here is twice the distance from the center of dilation. When a shape gets bigger like this, it's called an enlargement. Okay, then number 2, the scale factor is 1/4. So 1/4 means that this shape is going to get smaller, like 1/4 the size of the original. And just like before, the distance from the center of dilation to each point is going to be 1/4 the distance too. So I'm going to draw a segment here from C to the point. And then I'm just going to eyeball it and break it up into 4 equal pieces. So I broke it up in half, then broke this up in half and this up in half, and now I have fourths, like 1/4, 2/4, 3/4, 4/4. And R is at 1/4, so this right here is going to be my new point right here. And so from C to this point, drawing a segment, and it's going to be 1/4 the way. So just kind of breaking it up into 4 equal pieces as best I can. And then my point for my new square is going to go at 1/4. So I put a dot there at 1/4. Here, same thing, segment from C to the point on the square, break it up into fourths, and then I have a dot at 1/4. And then for the last part, break it up into fourths and put a dot right here. And so this here is my new shape. It is 1/4 the size, so each side length is 1/4 the size of the original, and each point is 1/4 the distance from the center of dilation. So when a shape gets smaller like this, it is called a reduction. Okay, so a couple notes that I want you to put just kind of in the center area. So an enlargement happens when the scale factor is greater than 1. So it's being multiplied by a number and getting larger. If the scale factor is equal to 1, it would just stay the same size in the same place. And a reduction is when something gets smaller. So the scale factor is less than 1. So for example, like 1/4 or 2/3. It's a fractional amount or a decimal. It wouldn't be negative, that wouldn't really make sense, but a fraction that's less than 1 would make it smaller. Okay, then over here, okay, we're going to practice this again over here. I'm going to do it with you because the numbers are kind of weird and it's best if I do it with you. So here we're going to do the same thing though. The scale factor is 3/2. 3/2, if you were to divide that out, is 1.5. So it is greater than 1, so this shape is going to get larger. But the same process, we're going to draw a segment from C to the point on the triangle. And then this segment has to be 1.5 times longer. So if this is 1, then halfway more would be like right here. So this would be 1.5, the original. Do the same thing here. If this is 1, then extending it another half, put a point right here. And then from C to this point, this segment, make it like half of this longer, would put it like right here. And then connect our dots to get our new triangle here. So this is 1.5 times larger than this, and all these points are 1.5 times the distance from the center of dilation. This is an enlargement because it's getting bigger. Okay, and then number 2, it's 2/3, so that is less than 1. Our shape's going to get smaller. What we're going to do is we're going to make segments like this from C to each point, just like we have been. I'm going to break it up into 3 equal pieces like this, and 2/3 would be right here, right? Because this would be 1/3, 2/3, 3/3. So like for this segment from C to C, I'll break it up into 3 equal pieces, and 2/3 would be right here. So this is the point to my new trapezoid. And so connecting this here from this point to this one, break it up into 3 equal pieces as best I can. New points right here. Connecting this, breaking up into 3 equal pieces. 2/3 would be right here. And then this segment, 3 equal pieces. 2/3 would be right here. And then last but not least, connect the dots, and here is my new shape. And it's getting smaller, so it is a reduction. Okay. Next. So now they're going to have drawn it for us, and then we just answer questions about it. One thing that they put in here that I wish they didn't add to it, because we're already kind of learning enough as it is that they put in like solve for x. So we're going to solve the x's first, so that way we can just focus on the new stuff. Like here it's saying this distance is x, this distance is 5, and the whole thing is 7. So x here would equal 2. So I'm just going to put that in there. X equals 2. Then over here, This distance is 2. It doesn't tell us this, but it says the whole thing is 5. So this x would equal 3. We're going to come back. There's more to this. I'm just doing like the simple part. Then number 3 over here, it says the whole thing is 15. This is 10 and this is x. So x would be 5. And then for this one, 1 plus 2, x is 3. Okay, now that we know x, we can just focus on the new stuff. Okay, so it says determine whether the dilation from k to k prime, so like the original to k prime, is an enlargement or a reduction. Then find the scale factor of the dilation and x. Okay, so k to k prime, looking at this, here's k prime. So k prime is larger than k, so this would be an enlargement. Okay, and then scale factor. So when we find scale factor, we're going to look at the new shape over the original. So it's going to be k prime, which is the new one, over k, which is the original. So we're going to look at the distance between the center of dilation and k prime, the new one. So the distance between k and k prime is, it tells us, is 7. And then the distance to k is 2. So this right here is our scale factor, 7/2. You could also put it as a decimal, 3.5. Same thing. So that's your scale factor. So this one is 3.5 times the size of this one. Okay, then number 4. So again, k to k prime. See, so k is the original, k prime is the new one. So the original is bigger than the new one, so it's getting smaller. So this would be a reduction. And again, when we find the scale factor, it is the new over the original. So the new one is only 2 units away, and the original is 5 units away. So scale factor is 2/5, or 0.4, if you want to think of it like a decimal. So this is 0.4 times the size of this, or 2/5 the size of this one. Okay, now we're going to practice it 2 more times over on the other side. So just like slide to the right. Over here. Okay, so first k to k prime. K is small, k prime is big, so that would be an enlargement. And scale factor, new over the original. So the new one, k prime, is 15 units away. The original is only 5 units away from the center of dilation, so divide that out and we get 3. That's the scale factor. So this is 3 times larger than this. Okay, and then this one, k to k prime, it is getting larger again, so it is an enlargement. Scale factor is the new over the original, or k prime over k, which k prime is at 3 units away, and then k is at 2. So our scale factor is 3/2, or as a decimal, 3 divided by 2 is 1.5. So the new one is 1.5 times bigger. Oh, sorry, I didn't realize it was in the frame. The new one is 1.5 times bigger than the original. Okay, for the next one, we're going to go ahead and do this on a graph now. So just bring in one more aspect with the same concept. And we're going to move over here. Okay, so it says, find the image of each polygon with the given vertices after dilation centered at the origin with the given scale factor. So they give us coordinates now. So I'm going to graph this original shape just quickly on the graph. So 2, 4, 1, 2, 3, 4. I got point J. K is at 4, 4. P is at 3, 2. Here's our shape. Okay, and in the problem it says the center of dilation is the origin. So center of dilation, and for most of the problems you deal with in geometry, the center of dilation is going to be the origin. So essentially, this length right here is going to double, and you're going to have J prime out here. This length right here is going to double, and P prime is going to be out here. And this length from the center of dilation to K is going to double, and K prime will be out there. There is an easier way to do it than just eyeballing it, like that's the concept, but we're going to look at the math as well. Here it says the scale factor is 2, so that's why this length is going to double. The other way to do it is to use the coordinates though. So for J prime, K prime, and P prime, since the scale factor is 2, we can actually multiply all these coordinates by 2. So 2 times all these numbers. And this hack only works when the center of dilation is at 0, but like I said, most of the problems you'll see at this level will be centered at the origin. So I'm going to do 2 times these coordinates, so that would be 4 and 8. So J prime is at 4, 8. The coordinates for K are 4 and 4, so 2 times that would be 8 and 8. And then for P prime, 2 times this would be 6 and 4. And then I'm going to graph these new points. So J prime at 4, 8, 1, 2, 3, 4, 2, 3, 4. J prime. 1, 2, 3. K prime. And okay. And then this is our answer. So this shape is 2 times the dimensions of this. So like all the side lengths are twice as long. And then each point here is twice the distance from the center of dilation. Okay, then number 6, we're going to do the same process. We're going to first graph our original points. -2, 0, 0, 2, 2, -2. Okay, so this shape, the center of dilation is at the origin. The scale factor right here is at 1.5. So the new shape is going to be 1.5 times larger, and then all the points are going to be 1.5 times the distance from the center of dilation. What we're going to do is multiply all these coordinates by 1.5. So 1.5 times all these numbers. And you might want to use a calculator sometimes if you need it. 1.5 times -2 is, I'm just doing it in the calculator, 1.5 times -2 is -3. So for D prime, I get -3, and 0 times 1.5 is just 0. G, 0 times 1.5 is 0, and 2 times 1.5 is 3. And then for F prime, 1.5 times 2 is +3. -2 times 1.5 would be -3. So then these are my new coordinates that I'm going to graph. -3, 0, D prime, 0, 3, G prime, and 3, -3, F prime. And then here's my new shape. It is 1.5 times larger than the original, and each point is 1.5 times the distance from the original point. We're almost done. Okay, then over on the other side, to be honest, these coordinates and points don't graph very well on the graph, so we're going to skip these. and we're just going to do number 7, and that's our last problem. So this is more of like a real life example that has to do with this. It says Estebe, I don't know if I'm saying that right, enlarged a 4x6" photograph by a factor of 5 halves. What are the dimensions of the new photograph? So we have a photograph. It's 4 inches by 6 inches, and they enlarge it. So we have a new photograph. It's enlarged by a scale factor of 5 halves. So like multiply by 5 halves to get the new dimensions. So we'll take each, so 4 inches times 5 halves and 6 inches times 5 halves to find the new dimensions for the photograph. So in a calculator, I would just do 4 times 5 divided by 2, get 10, and 6 times 5 divided by 2, and I get 15, so 10 inches by 15 inches, and those are my new dimensions. Sometimes what they'll ask is they'll just give the dimensions of the 2 photographs, and they'll ask for the scale factor. If you're asked for the scale factor, always do the new one over the original. This is the new photograph, this is the original. So you would just take a corresponding side with a corresponding side and just say, okay, 10 over 4. Simplify that, and you'll get the scale factor 5 halves. So if you need to work it backwards, just remember new over the original, and you'll get the scale factor that way too. Okay, and then last thing I need to tell you is that this is the last lesson in the note packet. So if you have everything filled in, turn in your note packet and I'll quickly get it graded and back to you. Yeah, 1 second. The last problem. Yeah, 1 second. Yeah. Okay, so turn in your chapter 4 notes if they're complete and then start the homework. 1 second, let me end this here. Yeah.